Okay, try that again. Chapter 10, Industrial, Agricultural, Vehicle, and Machinery Extrication, page 418. Commercial vehicles used for moving personnel and small amounts of material. I think this would fall more under the medium and heavy truck extrication. Why they put it here, I'm not sure. Couple of the different tractors. We have wheel tractors and crawlers or track mounted. We've all seen them around our areas. Vehicles, commercial vehicles like this, industrial, have attachments that are permanently mounted. Implements are only temporarily attached. So this bucket and the excavator are what we would call attachments. And on a tractor, something that was hauling, say, a pull-behind baler or a disker, those are called implements, just for some clarity. These all have their own set of unique challenges in extrications, and we'll get to that later in this chapter when we talk about the certain considerations. This is just going through them. Forklifts, lifting capacity, see them outdoors, indoors, warehouses. You see small ones like this to very, very large ones. We have with our industrial sector here from RGV, we have some very large forklifts right up to small forklifts. So again, all have unique challenges. Forklifts can operate on a variety of different fuels. Usually the indoor ones like this are battery operated or LPG, natural gases, and the larger outdoor ones are generally diesel and or propane. All forklifts have a cage, some sort of overhead protection, and while it does assist in a rollover, again, generally this is for protecting the operator from any falling product on top of him or her. Forklift constructions, okay, we just talked about that. So here is a combine, or a harvester as they call in the United States. And we know that this is for discharging agricultural products for removal off a field and to grain bins or elevators, and then turned into our lovely products on the shelves. These are generally very stable, but given the right condition on hills, there isn't enough force, they can tip over. Again, you see this. This is an attachment, although it can come off just like a bucket can. These are a part of this unit right now until it's taken off and replaced with a different header or a swather on the front of it. So again, unique challenges. And this one here looks like, I'd say this is probably corn, and you know there's definitely some hazards to rescuers there. The hazards with the harvesters is generally in the back here, and medical considerations. We've seen quite a few of these over the years where farm workers are going in to try and repair something or unclog something, and they get pulled in. And this is where lockout and tagout is critical importance. So features of these vehicles. Two-wheel drive vehicles can be prone to rollover on hillsides. So these are top heavy. And again, good operators, they know how to drive these. This is no different than us with our ATVs and side-by-sides. Same concept, enough force and enough slope and they can tip over. So the all-wheel drive, so we're talking about different means of locomotion of these vehicles. All-wheel drives can handle the poor traction, all-wheel steering, good maneuverability. The tracked ones, on the other hand, are much better for traction, and generally not controlled with a steering wheel, more of a lever system, like anyone's familiar with a skid steer. They're using a lever system to operate it and maneuver it. Again, I think all of these are all vulnerable to rollovers. Say it's the matter of the terrain and the speed and force at which the piece of equipment is moving at. Size and weight make these very difficult. They are, most of them. There are still a few out there with no cabs, very, very old. But the majority of them now have good rollover protection on their cabs. But the cab is generally very small in comparison to a piece of equipment itself. So it does create a difficulty for rescuers. And again, we're talking about stabilization and getting access to the person in the trail in the piece of equipment. So again, I just, here's the controls, the lever controls, and operate either the propulsion of the side-to-side movement, and also used for controlling some of the equipment, so buckets, things like that, are quite often are controlled by a joystick. Different power sources. A lot of these vehicles will have PTOs, so power takeoffs, that would operate implements that are attached to that tractor. We have hydraulic pumps that can raise and lower implements. Operators can get tangled up, and rescuers in PTOs. Hydraulic pumps, when we're raising and lowering implements. Where we see a lot of this sometimes too is snagging power lines. So again, it's assessment. The rollover protection is required by OSHA. Basically, it's protecting. So you see this one here, it's an open cab. If it does happen to roll over, just like we talked about in few previous chapters, this rollover this protection system is giving that operator some level of protection, as well as being seatbelted in. Different fuel types. Again, we see this not just with these vehicles, but it's with all vehicles: diesel, gasoline, LPG, electricity, natural gas fuels. All right. Fuel tank failure, shutoffs for flammable sources, and electricity. These can all add danger to fire and leave the rescuer. Have you guys experienced many rollovers of farm equipment in your area? And answer, not typically. No, there's been a few, but chance. I think the last one we had ended up being a recovery, body recovery. It was not a rescue. The tractor went over in a water source on the road home, and the farmer ultimately drowned inside the cab. I think in 25 years, I think I've been to 3 of these, so they're not common. Again, they have happened, and it's not to say that they can't, but not common with us. And if you guys have anyone out there has any experiences, please just type something and tell a little story. I'd be happy to hear it. So So braking systems on a lot of these vehicles, mounted inside the rear axle. They can be wet or dry systems, independent brakes locked together, the track brake systems. Again, there's a lot of, there's a paragraph there on 426 about brakes. Read through it. Will it be a question on the test? Probably not, but when the system, if they're on their side or rolled over, you want to have an idea of what kind of braking system they're using, because when we're working around it, if it engages, we want to know that its power's been isolated or a braking system's been isolated. I thought I got rid of that one. Jacks. So jacks that are on backhoes, trackhoes for stabilization. We see these on fire trucks, as called outriggers or stabilizers. And that's basically to keep this unit stable during its operation. Let me just see where So where these become very hazardous for us as rescuers is generally when they're working alongside open pits and they're digging and the ground collapses. These things can either help us or they can hinder us in terms of rescue and stabilization. If this falls sideways into a ditch, this could help us, and it also may not help us. But one things that we have to be very cautious about are the bucket, the teeth. We've got hydraulics. Again, it's all about locking up power. Specific size ups, especially in industrial and agricultural vehicles. Like everything, systematic assessment. So overall scene, what vehicles are involved, do we have trapped patients, and ultimately what's required for extrication for this particular scene. These are questions that we need to be asking, okay? Questions to ask when nearing the scene. What's the location? If we need to get additional resources, is it out in the middle of a field? Is it one of those, lots of times we've gone to calls where the farmer meets us at the gate and escorts command in, right? The initial vehicle. What about the rest of your units? Do they know how to get in? So again, these are some things that you have to start asking yourself. Remote locations, how fast is it going to take us to get resources here? If it takes you a while to get out to this scene, you may want to think about getting resources on alert. So again, just questions to think about. And there's a whole list of questions on 427 and 428. I encourage everyone to just go through and read those questions. Again, these are things that you're going to want to think about en route to scene and then when you get on scene. I see questions. So the load questions, what type, contents, can we see it? Does it have an effect on the vehicle stability? A transport truck with grain, does that alter the stability of the truck when it's on its side? Yes, maybe no. Again, it's all about assessment. Hazardous materials. Placards are not always present on vehicles. If they're on major highways, yes, they should. But if anybody knows, if anybody in our areas, in our service areas, that not all farms and all small companies, when they're transporting small distances, have placards, unless they're governed by oil field. But again, just things to keep. Does it happen often? No, but again, it's all about complacency and making sure that as an IC and a truck officer, unit officer, that you're constantly assessing and looking around to see what you're challenged with with each individual incident. So has anyone seen placards on self-propelled sprayers on roads? No, as I'm sure that the agricultural community has probably found some loophole that they don't have to, just as combines can drive 50 kilometers an hour down Highway 16, causing nothing but. James says no. Okay. So other considerations that we want to think about, patient concerns. Do we need specialized equipment for extrication of the patient? Key points to consider including using airbags to lift equipment. All about vehicle stabilization. Anyone that's used airbags knows that you want to, when you're using airbags, that you're constantly stabilizing, cribbing what you're lifting. Airbags can fail, they can slip, and again, that can cause further damage to the patient and possibly rescuers. So the using airbag systems, it takes training, it takes knowledge, and it's not something that you just do lightly, especially when you're talking about in this kind of situation. There's a number of hazards here that are just screaming out at you. So again, SOPs, training. Methods for stabilizing industrial and agricultural vehicles. And we are on we're on 430 in that area. So when a vehicle is on its side, upright, upside down, different stabilization techniques. If it's upright, we want to look at stabilizing any damaged suspension, because if that fails when we're on a piece of equipment, near it, under it, it poses a hazard to rescuers and further damage to the patient. Immobilizing wheels, again, like any vehicle, we want to immobilize best we can, but large wheels, a little piece of a little wedge isn't going to work. So we may have to look at a combination of items or a combination of cribbing to keep wheels immobilized. On its side, it may appear stable, and again, we look at lots of different locations where unstable earth, ditches. Again, it's all about assessment. On its side, it can continue to roll further with movement. So we want to secure it, and whether that's a winch, that's cribbing, installing shoring on the underside, or our rescue jacks. Anything that you can to keep it stabilized, and especially with these are things we definitely want to look at, just simply because of the sheer weight and the unpredictability of all these vehicles. They're a lot different than a normal passenger car that say we can throw up some cribbing and a quick rescue jack, make a roof cut, and Bob's your uncle, patience out with with pretty successful stability. On these kinds of equipment, we really have to make sure that we're doing a really good assessment on all of the potentials. So it's the vehicle location, the vehicle size, what damage there was to it that's going to cause us some problems. So again, upside down, very unstable. Box cribbing, simply because anyone that knows seen a tractor, say very high from and a very unstable tipping point, and again, if it's in a triangle, you know what, that's probably pretty stable. You say you want to put one or two jacks in the middle underneath, and you've got quite a stable environment. If it's on the side of a hill or on a slope, again, it completely changes it. And not that this is any different from normal vehicles with the location. Page. Sorry. Thanks, Chris. The location can always change the entire situation from very easy to very complex. So again, solid. We want to make sure that we've got solid cribbing, and this is basically, most importantly, to protect us when we're working around that equipment in attempts to extricate the operator. Other positions can require long shoring from the top. Shoring that you would use that on a weakened building. Again, you're talking about large tractors. I haven't seen large tractors tip over yet. Generally it's the smaller tractors. You're talking about the little ones. The bigger ones generally, they're a large investment that most farm companies and farmers will treat quite well. Okay. Gaining access into industrial and agricultural vehicles. And that's 432. One thing to note that a lot of agricultural vehicles actually use plexiglass that I actually did not know. So plexiglass is not easily cut and to get access to. Right? Most tractors have one door, generally on the front or the side where they climb the ladder to get in. So taking the windows out of consideration, using the doors, you have limited access. If it's on its roof, you have to remember that the strong point that's protecting the rescuer and the patient is that roof. So we have to be very careful about removing glass, and how does that affect structural ability. So there you can see, this is a grader. There's the door, and that's the only one door they have access into it. Here's where the strength, if it was to tip over, you've got strength on here. It's a rollover protection, okay? And when we remove anything, we have to remember that we're also affecting the strength of this whole unit. So again, assessment. So either through the roof panels, or cutting through the top of the roof if we absolutely had to. They're thin metals, fiberglass, or plastic. It will have cross members. That's where it gets its rollover strength from. So again, peeling back a portion of the roof covering before we start cutting, simply because we don't want to cut through something. We don't want to cut through something that's going to wreck it structurally. There's a big caution on page 433. Cutting or removing part of an intact rollover protection system may cause the vehicle to fail. And if we have rescuers in there, they're a part of that failure. So. And there's a good warning there, one to take note of. Unless you are sure of it and safe to do so, never reverse the machinery in an attempt to free the patient. And that's when you got a patient that's caught in something. That's something that I would never do. And the best person to ask is someone who knows that piece of equipment. If you're very familiar with farm equipment, and again, that's an IC call that you would decide if that's how you want to disentangle a patient from a piece of equipment. Tactics. Disentanglement, patient removal both include several considerations. So cutting or removing a rollover protection system. We want to make sure that that is a last resort if possible, simply because that gets strength. Now, if it's on its roof, can we cut it? Yeah, let's have at her. If we needed to get access to a patient, if it's on its side or on its roof, again, we have to really assess that. Disentanglement. Generally, there isn't a lot of, you won't get a lot of patient damage. I mean, depending on the vehicle itself, but these generally aren't moving at high rates of speed. And not like a vehicle accident where the vehicle crushes around patients. You don't generally see that in agricultural equipment. Dismantling the cab, okay. Again, we're always focusing on the structurability and what the location of the equipment itself is, and what its position is. Tools and techniques. There is a farm machinery extrication course that deals specifically with teaching people these different techniques. It's a good course. Again, we've taken it, I don't know how many years ago, but it's not something that is widely used. So always good to have that kind of training, but again, it's priority for your department. But there's a lot of tools and techniques. There's a lot of stuff online. And then we want to dismantle the vehicle to free the patient. There's limited working room inside these cabs. So like you saw with the grader, it's usually a seat, enough room for a lunchbox, and a couple of cans of pop, and that's pretty full. So you have to take that into consideration. How do we do C-spine? How do we get hands in there to free and get the patient out? So they're saying it's faster and less traumatic to remove the cab first. Again, this is completely on location, right? Back to PTO shafts. They transmit power to implements. This was a common problem that the medical professions had to attend to. People putting their hands in wrong locations without disconnect, isolating the power. Okay, these are they're very dangerous, and they spin with enormous amounts of speed and torque. So if we are working around these as rescuers, we want to make sure that this power is isolated. And again, who knows that? People who are familiar with equipment. And I'm sure there's somebody that on every department that's familiar with some of these equipment. And that goes to back to this one. If you get a call for this, it's not a bad idea to know from a command perspective or an officer perspective who has knowledge of this equipment. Load your truck up with these guys, because they're going to be your knowledge at this rescue. They can hinder you also, because I'm sure they've done a few things backwards or improperly in their time. But again, it's a good thing to do. Use the people, use the resources you have, because that's what they are. Extrication procedures, pre-incident planning. So here we're looking at an equipment shop. I'm sure every community has these, whether it's an indoor crane, it can be something with augers. I'm sure every town has a grain elevator. These are all industrial equipment and machinery that poses a hazard. Have we been to any? Not that I can recall, but we still have to train and know about these things. Again, there's a lot of staff here. Let's just say this is a grain elevator. Those guys know that elevator inside and out, and that's a resource. So we want to make sure that we've got the right people and the right resources there. All too often, as first responders, we're trying to clear the area, make it a freer area for workspace for us. But just remember that these guys have the knowledge. Use them. Okay. So different variety of tools. We got things used in other rescue disciplines, so ropes and lock and tackles, chains, those kinds of things. Lockout, tagout devices. That's very important, especially if you're working in in an industrial shop area. When we are in there doing a rescue, okay, it is our responsibility, according to by OH&S rules, to lock out. It's not our responsibility to ask the owner to lock it out. We should actually have our lockout system ourselves. And I encourage every department to have a lockout tagout system in their command unit or their first response unit. Even something as simple as working out in the field that has an electric fence and disengaging it and locking it out yourself. Okay, never trusting someone else to do that for you. So phase one includes a primary and secondary assessment, and you can find this on page 436. So your primary assessment, just like always, you're sizing up what resources do we need, and then more size up, right? That's what our primary is all about. What do we need? What do we got? What do we need, ultimately? Secondary is starting to gather some information about what we're dealing with. So our machine, the vehicle, the piece of equipment that we're working with, okay? Then classifying it, what condition it is in, what is the patient status? Again, are we going to risk life and limb of our own if we're certain that it's a recovery, not a rescue? So again, that all comes up in our size up, and then gathering. And it's not just gathering information about the machine; it's about gathering information about the whole incident. And that's one of the skills that we've been preaching the last weekend, was gathering information, getting data to incident command so that they can make an informed decision. So phase two, monitoring the patient, monitoring vital signs, keeping patient conversation. That was something that we were stressing at all our vehicle scenarios, was maintaining contact with the patient, not leaving them alone, so that they know that we're still here and that what we're doing, because that's a benefit to EMS by trying to keep our patients as calm as possible. The incident action plan, okay. Once you've gathered all your information and IC has developed a plan, and the plan doesn't have to be all him, right? That's why you have the trained people within your department, the knowledge. Use their knowledge. If there's a way that looks, that seems that it'll work and you're comfortable with it and you trust them, okay? Ultimately it's the IC's decision, but once it's finalized, it has to be communicated to everybody so that everybody's on the same page. If you say we're cutting here and that's what your plan is, and you haven't communicated it to somebody, and you say, well, I just want the roof taken off, then you can't complain afterwards if things aren't done the way you like them, unless it's communicated, all right, and clearly communicated. Your incident action plan at all these incidents, okay, it's a guide, so it needs to be flexible. It needs to be able to be adjusted depending on how the situation plays out, okay? And it needs to accommodate the rescue, needs to always have a backup plan, okay, or an escape plan, a rescue plan, that if something goes sideways and your rescuers are hurt, what's the backup plan, okay? And in good rescue command, okay, that's always the in the back of your mind is what's your plan should something go south. The elevator. So what do you mean is the the evaluator? Sorry, I think you said elevator. No, it won't have to be. It's not written. It's only written in an incident command or an ICS situation. Some people can write out the plan so that it is identified, and that was something that Matt had brought up on the weekend, that they use their board, right? That board is ultimately a written IAP, but it doesn't have to be, as long as when he asks that the IC or the officers, who are basically anybody in the situation, they should know what's going on. Does that answer your question? So phase 2 includes pre-extrication ops. So resources, do the resources affect what's in your action plan? Does your action plan have the right number of personnel? Don't make an action plan that you can't effectively accomplish without the right equipment and the right personnel. So it has to be adaptable. The atmosphere, the immediate area, is it snowing? Is it blowing wind? Is it cold? Is it hot, rainy? We have to take everything into consideration. Even if we're indoors, what happens from the patient transfer from inside to outside? Detectors, if we're in a volatile area, again, grain elevators, right? Where the grain dust explosions, even hantavirus, you probably won't see the elevator workers going in there without masks, and yet we'll go running in there. So again, all these things have to come into play when you start thinking about what your atmosphere that you're working in. Ventilation, if required, where's ventilation? Is it on the right truck? You're out in an agricultural setting. Do you have ventilation on those on your rural trucks? So again, you find out a lot of this stuff in pre-planning too. If you have to go out to a situation, do we have access to that? Lighting, if power goes out, do you have enough portable lights? Can we get portable lights to that situation? So again, these are all just things that you have to think about when it comes down to your atmosphere. Oh, there we go. Using intrinsically safe, especially if you're in a volatile situation, environment. And communications, right? We've talked, that was the mother of all failures in any situation. It's usually communications that go. So establish the incident action plan, an incident command post, okay? If not close enough to the patient, to see the patient. How do we communicate what I see once, over to the scene over here if we're far away? Are our communications intrinsically safe? These are all things that we have to take into consideration depending on our atmospheric location. And again, phase 3, the actual extrication can only begin after zero mechanical state is achieved. So how are we going to do that? Lockout, tagout? Is it someone, if we don't have a lockout, tagout system, do we sacrifice a rescuer to stand right by the power source to ensure that it doesn't get turned on? Again, who's going to do that? Is it the rookie that when somebody comes to turn on the power because they said it's okay? Again, this is all a part of, we want to make sure that there's nothing that's going to be able to move and hurt our rescuers. Okay, they always have to be very cognizant of that. And when we're getting into machines like this, are we taking the machine apart to get at somebody? If they fell in, falling into, you think of our big grain elevators. If there's an area that someone fell into a grain bin or fell into a tight area, they're not simple pulling people out. You may have to get in there and start removing machinery and equipment or disassembling part of it. Who can do that? Is that something we do, or do we monitor and use the professionals that know that equipment? Again, that's all part of your assessment and part of your plan, and to have it in place before anything happens. So, so weighing your time needed against patient condition. If you've got time, then do it more safe than if it was a rapid extrication. Stabilizing the machine may require a technical expert. Again, every situation we go to, okay, if we have to wait to make sure that the area is safe for us and our rescuers and the patient, then we do so. It's as simple as that. But we use the people that know how to know that equipment best. It's not something that we want to start guessing ourselves when we get on scene. Isolating energy sources, critical aspect. And again, when we get, we're not going to have any situations that I don't think during the scenarios, but the evaluator might ask, what if, if there was a piece of equipment there, what's one of our biggest considerations, right? It's always locking out power. Here's where it said stay with a rescuer to stay if not available. Again, is that a great resource? How does that person, what person are you going to put in that position that's going to be able to, ward off any people from the company that might want to come and turn the power back on? So again, will it happen? Probably very low risk, but it's something we always have to consideration, because the moment you don't do it, that's when a rescuer will get hurt and caught or killed. So there's two ways to extricate in these machineries. So we either manipulate the patient or the mechanism that they're trapped in is manipulated. Is that any different than a normal vehicle? No, I don't think so. So if you can manipulate a patient safely without incurring more injury by twisting a patient, as long as we're maintaining C-spine or whatever our EMS say that they're requiring, then we do that, right? That's probably easier to manipulate the patient rather than, and it was really kind of, lubricant may be useful. I wasn't sure where they were going with that, but I'm not sure I would dump a bunch of lube on somebody to manipulate them out of anything. So, um, so this is much easier than removing this, in my opinion. Now, if this piece of equipment is just a 5 or 6 bolts and some panel comes off and there he is, have access to him, great. But again, that's all back a couple of slides, okay, about assessing your situation and coming up with that action plan, right? And if the action plan isn't seem like it's working, what's our next plan of attack, right? Constantly assessing and reviewing your IAP. So here we have this picture in a press, all right? So disassembling the machine, okay? I wouldn't want to touch one of them, okay? I don't work with them, and there may be somebody out there that in the class that does and has a great knowledge of them, and they probably say they're the safest things in the world, and they probably are, right up until you don't know how to use them. So it's just like a combine, it's just like a grader, just like a backhoe. They look dangerous, until and they are dangerous until you know how to treat them. It's no different than fire. Everybody says fire is dangerous. It is, but we also know how to treat it properly, and we know what to do with it. So that's why people shouldn't fight their own fires, just like we shouldn't go and tear apart people's tools. So. Forcing the machine. So if you're trying to forcibly, manipulate a machine to free a patient, okay, that just has nothing but problems written all over it. It has further damage to rescuers or further damage to the patient. It has new damage to rescuers. Again, consult with the operators. If you have to force a machine, and that can be, and so when we talk about this, when we're cutting a post on a car, this is ultimately what we're doing, right? We're forcing the machine to remove that to get access. So we're protecting the patient and extrication personnel, whether that's a blanket, whether it's the board, a tarp from glass. So it doesn't really matter if you're in a car or you're in an industrial machine, right? We want to protect our people and the patient as best as we can. Tools should be controllable. So again, our tools, our hydraulics, are they controllable? Yes, right? Just little flicks of the switch, slowly. And it was identified, our tools on the weekend, that the cutters may need to be retorqued, simply because when they start cutting through, if it's a stronger metal, the tip of the blade was actually separating about a 1/16 to a 1/4 of an inch. That may not seem a lot, but evidently it is, and there's a potential for a problem to happen from that specific tool. Phase 4, once extrication is accomplished, so now we're into termination. Termination was the getting everything back into place, back into a station-ready service, debriefing, and an after-action review. And we went through that on Saturday with the big scenario. They can be done in conjunction with each other, but they have to be done. And generally, if you're freeing somebody from a trapped piece of equipment, chances are it's not going to be pretty. So, again, debriefing there has to be a debrief with every situation. It's just the complexity of the debrief changes with each situation. So summary: in order to function safely and efficiently at these incidents, personnel must be familiar with the anatomy of types of vehicles and machinery that are common in the response area. This, again, that's pre-planning, that's training, that's knowledge of what you're responding to. What we respond here may not be what they, they may have some special equipment in St. Paul that we don't know about. And, Beaver County you could have a shop in your community, or a machine shop, an industrial shop that has equipment that, some people will never be around. So again, it's understanding what's in your community. Rescue personnel must keep in mind that their role is to protect themselves and others from harm, protect the trapped patients from further harm, and to free those patients as safely and as quickly as possible. And in that order, always protect themselves, okay? Protect others. And if that means, getting other resources like RCMP involved to keep people away, that's what we want to do. A farm incident, I did hear of one many years ago, north of us, where a child was in an accident with a piece of farm machinery, and all the farm hands, the neighbors, everybody, and then when fire and EMS got on scene, it's an absolute chaos, and everybody stands back, a little bit, lets them in, and then, once they're doing their assessments and, gathering their information, it creates hostility from, the family and standbyers, to say, well, get in there, right? But they're very familiar with this equipment. So again, it's easy for them to jump in because they know exactly what they're doing. And, we have to protect our people first. And most people, don't really understand that. So again, just things to keep in mind. And that's that one. Let's take a quick 5-minute pee break, and we're on to